In this concept, we're going to talk about properties of equality. And these are the properties that will allow you to manipulate expressions on both sides of an equal sign. Okay? Let's look at some examples of these properties. So an addition or the addition property of equality is the property whereby for any expression, for any two equal expressions, if you add the same expression to both of them, then they remain equal, right? So if we have expressions a, b, and c, and if a is equal to b, then adding c to a and adding c to b keeps a and b the same. So a plus c remains the same as b plus c, right? So we went from a equals b to a plus c equals b plus c. Okay, that is the addition property of equality. Here are some examples. So let's look at expressions x and y. If they happen to be equal, if you were to evaluate them and they turn out to be equal, such that x and y are equal, then x plus a is equal to y plus a. If x minus 2 is equal to 3, these are two expressions, right? X minus 2 and 3. Then x minus 2 plus 2 is the same as 3 plus 2. Okay, so adding the same value or the same constant to both sides keeps both expressions equal. The other property of equality is the subtraction property, okay, and it's very similar to the addition property, but obviously it involves subtraction instead of addition. Now, for any numbers a, b, and c, if a equals b, then a minus c is equal to b minus c. So subtracting the same expression or number or value from both initial expressions keeps the equality constant. Okay. Examples are if x equals y, then x minus a is equal to y minus a. If x plus 2 equals 3, then x plus 2 minus 2 is equal to 3 minus 2. Okay, so subtracting 2 from both expressions keeps the equality the same. The next property is the multiplication property of equality, and obviously that involves multiplication. For any non-zero numbers a, b, and c, if a equals b, then again multiplying a and b by the same constant c keeps the equality the same. Examples are if x equals y, then x times a is equal to y times a. Okay. If x over 5 equals 10, then multiplying by 5 on both sides keeps the equality the same. And this is how it is important, how this gets important when you're solving equations and you need to manipulate things and simplify one side or the other, right? So in this case, for let's work it out. So x over 5 equals 10. So if I multiply by 5, what do I get? So this 5 cancels with the denominator, right? So I get x, and now I've separated the x by itself, equals 10 times 5, which is 50, right? So I just solved. I went from this, right, to this. So I solved for x. This is where something like this would be useful. Another example, if t over 2 equals 3/5, then again, multiplying by 2 on both sides keeps the equality ongoing, right? So t over 2 times 2, the 2's cancel, right? And you end up with t. And then 3/5 times 2, so 3 times 2 is 6 over 5, right? So 6 over 5. And with a t on the other side, so t equals 6 over 5, which we can simplify to 1 1/5. Okay. Next example, if 1.5x is equal to 13 over 14, then we can first rewrite as an improper fraction, right? So 1.5 becomes 3/2 x, and that's equal to 13 over 14. Okay, so how do we get it? We would like to isolate the x by itself so we could solve for it. How do we do that? Well, we multiply by the reciprocal of 3/2, by the reciprocal of the coefficient of x, in this case it being 3/2. So we have 3/2 times 2/3, and those cancel out, and then you just get x on the one side, right? 13 over 14, and then so you have to multiply by 2/3 here also, in which case you get, divided by 2 is 1, divided by 2 is 2, so 2 times 3 is 6, so 13 over 6, right, which is equal to 2 1/6. Okay. Now the next property of equality is the division property, and it obviously involves division for any numbers a, b, and c, where c is not equal to 0. If a equals b, then dividing by the same number keeps the equality the same, right? So as long as c is not 0. If c were 0, then you'd go into higher level concepts that are beyond the scope of what we're discussing here. But in this case, you just need to know that you can't, since you can't divide by 0, right? So assuming c is not 0, then you have by dividing by c, they both expressions remain the same. So a over c remains equal to b over c. Some examples: if 5x is equal to 10, then 5x over 5 is equal to 10 over 5. Again, dividing by 5 on both sides, to simplify. So 5's cancel. You get x equals 10 over 5, which is 2, right? So now we've just solved this. Okay. Another example: if x equals y, then x over 5 is equal to y over 5. Just simply dividing both sides by 5. The reflexive property of equality. Now this one kind of looks, very common sense and very straightforward, to the point of almost looking trivial, but it's not. Sometimes you have to, realize that something is equal to itself, and if 10 is equal to 10, 4x is equal to 4x. Again, it is something you have to be mindful of when solving equalities or equations. Another property of equality is the symmetric property of equality, and again, this one is kind of straightforward, but in certain circumstances, it may come up that you need to be aware of it. If a is equal to b, then b is equal to a. You can flip the items on both sides of an equal sign without issue. Okay. Example is, if 6 is equal to x, then x is equal to 6. The transitive property of equality. If a is equal to b and b is equal to c, then a is equal to c. Okay, if you have more than two expressions that have an equal relationship, then the additional expressions beyond the two can be equated together. So a and b are equal, and b and c are equal, so a and c are equal. Right? There was no direct relationship between a and c given these two equations, but we can draw that relationship again based on the transitive property of equality. Here's an example: if x is equal to y and y is equal to 3, then x is equal to 3. Okay. Another property of equality is the substitution property, and the substitution property is essentially being able to replace something by the other based on an equality. Okay. So for example, if a equals b, then a may be replaced by b. So if x is equal to 5, then 5x is equal to 5 times 3, which is 15. Okay, and oh, I think this is a typo. So right, I'm sorry. This should be 5 times 5, right, which is 25, right? So x is 5. So then 5 times x, which is 5, right, is 5 times 5, which is 25. Okay, I hope this was clear. This is it for this concept. See you in the next video.